Welcome to the Engineering Update. I'm Associate Editor Jamie Wisniewski, and in this week's episode, test firing a 3D printed thruster, the first step toward a flying car, and exoskeleton to lighten the load for industrial workers. We're 3D printing a lot of stuff these days.
The first 3D printed battery-powered rocket.
Things like 3D printed skulls, the world's first 3D printed jet engine. See what I mean? But with each discovery, it seems the 3D printing items are evolving in terms of sophistication and application. For example, the European Space Agency, or ESA, has 3D printed a platinum alloy thruster, combustion chamber, and nozzle. And not only has the agency printed it, but they've also test-fired a prototype. Utilizing a laser printing machine designed for jewelry, the thruster was printed using a platinum rhodium alloy. The layer-by-layer printing technique cuts down on waste as it doesn't require slowly cutting away at a solid block of material. And at $63 a gram, platinum ain't cheap. Obviously, 3D printing offers a few different benefits in terms of saving money and time, but the group wasn't even sure the technique of using a laser beam applied to a metal powder bed would result in a thruster that could even be used. But after 618 ignition tests with a maximum temperature of 2,287 degrees Fahrenheit, the results are looking pretty good. This was the ESA's first foray into using additive manufacturing for this type of part, but the next test on the horizon will be utilizing different materials to see if they hold up. The next alloy will be platinum iridium. If successful, this will mean the industry can now utilize the performance benefits of that particular alloy, which can't be easily manufactured using traditional techniques. Other potential materials include copper and Inconel. German company Volo has revealed a design for a personal helicopter it says could be the first step towards an electric flying car. The Volocopter looks like a helicopter, but is a two-seater drone that can take off and land vertically. It uses 18 rotors, which Volo says makes the drone safer, simpler, and cleaner than current designs. It also runs entirely on rechargeable electric batteries. The initial two-seat design uses battery packs with a flight time duration of only about 20 to 30 minutes, but the company is working to develop a hybrid power system that would extend flight time to over 1 hour. Volo made the world's first manned flight with an electric multicopter in 2011, where the pilot sat in the open air on top of a set of rotors. It looks something that could only be manned by a stuntman, but it has evolved into the Volocopter, which looks more like a commercial helicopter. The key difference is that it's designed to be flown by anyone. You fly using a simple joystick, and it's much more stable than a helicopter. The Volocopter made its first remotely piloted flight back in 2013, but Volo says its first manned flight is about to take place. The company hopes it could change the way we travel, replacing both planes and cars, but priced at $340,000, it's unlikely it'll replace the family car anytime soon.
Powered exoskeletons aren't a new concept. They've been used in laboratories, the military, and areas such as rehabilitation therapy for years. Never, however, have they been used in the industrial industry, where constant heavy lifting is still very much a part of many working lives. The RoboMate project is hoping to change this with their exoskeleton designed specifically for industrial use and can make 22 pounds feel like merely 2. Automation has cut down on a lot of the heavy lifting, but not all lifting has been eliminated. In some industries, workers often lift up to 22,000 pounds of materials a day. The RoboMate project started in 2013 with 12 research institutes and companies in 7 European countries. The idea is to produce a powered exoskeleton that acts as a support frame that can reduce the physical workload for assembly and disassembly work by a factor of 10. The exoskeleton is made up of a series of inter-supporting modules for the arms, trunk, and legs. The arm modules actively support the wearer's arms, taking the load so it feels only a tenth of its real weight. Attached to the arm modules is the trunk module, which supports the back and spine and prevents twisting or slipped discs. Meanwhile, the leg modules support the inner thighs and act like a seat while squatting, so holding the load requires no additional strength. The project team developed the exoskeleton using software to simulate tasks involving assembly and disassembly, and then identified the stresses placed upon the body. This allowed them to sort out which tasks are suitable by considering it and the body as a single unit. The project is still in the prototype stage, but the team hopes eventually it can be used by industry workers as an everyday tool.
That's all for this week's video. Be sure to check in on Facebook and Twitter and catch past episodes at ecnmag.com. For the ECN channel, I'm Casey Panetta, and this has been your Engineering Update. And see.